Today we're at the sports engineering lab to compare two different types of kicks. The first kick is a jumping front kick and the second kick is a normal front kick. Today we have Spencer as our test subject. He has a black belt in Taekwondo and he has been doing Taekwondo for 6 years. He will now execute both kicks and then we will calculate and analyze the data.
So now we are recording the amount of ground reaction force with the software Byware. And basically there is a force plate on the ground. And it will calculate the amount of force placed on the plate. Spencer, can you demonstrate putting force? Okay, so that footwork will generate a graph. So yeah, that's it. So now we'll be doing the front kick. Okay. And then that's the amount of force. The highest peak is the one that we need to calculate.
As seen in the graph, it stands at 1,100 newtons of ground reaction force generated from a normal front kick. As for the jumping front kick, the ground reaction force is higher as there was a short run-up, resulting in more force planted during the preparatory phase before the execution of the kick, which stands at about 2,500 newtons. For the jumping front kick, the ankle is dorsiflexed to build up the maximum force. The force generated will transfer from the ankles to the knees, then to the hip, which allows full extension of the leg with maximum amount of force transferred to the distal joint, which is the ankle. For the front kick, it is similar to the jumping front kick. The ground reaction force is transferred from the ankle to the knee, then to the hip, to the right knee, then to the most distal joint, which is the right ankle, and which is also the point of contact. For impulse momentum theory, we can use the distance from the jump to the point of contact, divided by the time recorded for the leg to travel at the distance to measure the speed of the kick. For the front kick, it is 1.86 meters divided by 20 milliseconds, which will result in a 9.3 meters per second traveled. And then for the jumping front kick, we take 1.8 meters divided by 12 milliseconds, which will result to 15.5 meters per second. Thus, it is evident that the jumping front kick has a greater velocity compared to the normal front kick, and the point of contact at the ankle is definitely travelling faster, which means that it has a greater impulse momentum.
So that's the end of the analysis. So I hope you guys enjoyed it. We start no lah.